Miss Antonio Nathaniel here, and today we'll be beginning with statistics. And this statistics is a part of mathematics that has to do with calculations involving bar charts, pie charts, your pie graph, histograms, and all the rest of charts and graphs. And probability has to do with the chance of an event happening. That is what probability is about. Now, when we talk about bar chart, you can see in this diagram we're talking about pie chart here. And now I will give a first example to illustrate what I'm trying to say. So in this case, we have table 18.1 shows how an income of 15,000 is spent. Show this information on the bar chart. Now in this case, in this particular question, we have a table here, and then we have to show the information on the bar chart. Now you can see in the first column you have the column of food, rent, clothing, savings, and other expenses. Then you also have the respective amount in the second column. Now what you are going to do is you are going to draw you make use of a Cartesian plane. You represent the items by bars of the same width. The height or length of each bar is proportional to the amount of money. Figure 80.1 shows the bars, which may be vertical or horizontal. So first, let's draw the bars vertically. So as you can see, the vertical height of the bars represents the magnitude of the amount which they represent. So you can see that we have 5 green rectangles here. The tallest of those rectangles represent the highest amount of money. Then the shortest rectangle represents the smallest amount of money. So the height is proportional to the value being measured. So now here we have another way of representing the bar chart. So this is called the horizontal method. So if you notice, if you are apt and you are very good at recognizing patterns, you will notice that this second one is still the same as the first one, only that in this case we have the rectangles, they are horizontal. So in the first case we had vertical rectangles, but in this case we have horizontal rectangles. But no matter what orientation you have your rectangles, they are still bar charts. So you can have either your vertical or horizontal bar chart. But as you can see here, the horizontal height is still proportional to the quantity it measures. So on the horizontal scale we have the scale of 2,500 naira and 5,000 naira. So this is the magnitude being represented, and this is how to draw a bar chart. Now, assuming that you have not been able to understand the first example sufficiently, this is another example that is going to make it easy for you to understand. And in this second example, we're talking about the number of students admitted to a university in a particular year, which is distributed among 5 faculties. So the 5 faculties are education, 350 students, medicine, 150 students, engineering, 200 students, law, 100 students, and arts, 100 students. Now we have to draw a pie chart to represent this information. Now, if you have had some experience with Excel, you will know that when you get to the charts tab on the Excel menu bar, there's an option for you to draw bar charts. Now these bar charts, they are basically charts, and then we also have pie charts. Now that's what we're drawing here, pie charts. And the pie charts, they are basically is a circle which is divided into different sectors, and those sectorial angles are proportional to the magnitude of the quantity they represent. So in this case, before you draw a pie chart, the first thing you are supposed to do is you are supposed to have the angles of the sectors of the pie chart. So first of all, we have the table here. So in this table, we are going to use it to represent the angles. So in the first column, we have the different distribution of students. We have education, medicine, engineering, law, and so on. Then in the second column, we have the number of students for each respective discipline. Then in the third column, you have the multiplication of the relative fraction of each number of students multiplied by the total angle in a circle, which is 360 degrees. So what you are going to do is you multiply the relative fraction. In the second column, you can see for education, it has number of students of 350. Then the total is 900. So when you get the relative fraction, that would be 350 over 900. Then you multiply that by the total angle of the sector. So and that would give you the angle of the sector that you are going to draw. You can see that we have the pie charts drawn here, and we have different colors for the different sectorial angles. So for example, in the first case, we have the color of light yellow for education, we have light purple for medicine, then engineering, then law, and then art. So this is how a pie chart works if you are drawing it using a software. But if you are drawing it with your hand, which is using a compass and a pencil, so you also draw a circle and you divide the circle using your protractor into different angles. That is how to draw a pie chart. So here we go. We have another example here which deals with pie chart. Now we have that the pie chart in figure 18.3 shows the distribution of marks scored by 200 students in a test. Now in this case, we have the circle with the sectors and each of the sectorial angles already sketched for us. So what we are asked to do is we are looking for how many students scored between 41 and 50 marks above 60 marks. Then question B, what fraction of the students scored at most 50 marks? Question C, what is the model class? Now let's answer this question step by step. For the first question, we asked how many students scored between 41 and 50 marks. So all you need to do is you look for the class of that falls between 41 and 50. And from the key, you can see that that is the purple sector. So that's purple sector, it is the class. So when we're looking for the number of students, all you need to do is you need to look for the relative angle and multiply by the total number of students. So what I mean is the relative angle is the ratio, or rather the fraction between the actual angle of that sector and the total angle in a circle, which is 360 degrees. So in this case, the number of students will be 18 degrees over 360 times the total number of students, which is 200. That's 18 over 360 times 200. That's 10 students. Now, in the second part of the question A, we also have above 60 mark. We still use the same method, but in this case, note that we're looking for a range. So we are not using just one class, we are using 3 classes. Now, in this case, we are using 61 to 70, 71 to 80, and 81 to 90. Now, all you need to do is you look for the classes. For the 61 to 70 class, we have it as it is a light blue class. Then for the 71 to 80 class, we have it as the light orange. Then for the 81 to 90, it is the light green class. So when we add together the angles in these classes, we'll get a total of 252 degrees. When we look for the relative angle, which is 252 over 360, you multiply by the total number of students, that is 140 students in that required sector. Now, continuing from where we stopped, that is not the end of the question. We still have 2 more sub questions, and that is question B, which says the student scoring at most 50, and that appears at the 31 to 40 and 41 to 50 sectors. So that is the student that scored lower than 50 or 50. When we add the total angle, that's 72, and the fraction will be 1/5. So what we are looking for here is just the fraction of students that scored at most 50 marks. And lastly, we have the model class, which is the 71 to 80 class, because it has the largest sector. Now, if you are asked to look for the model class in mathematics, it all has to do with the class that has the highest frequency, the highest height in a bar chart, or the highest sector in a pie chart. So depending on what you are given. Moments ago, I was talking about model class. So now let's kick off from there and let's talk about the mean, median, and mode. Given a set of values, the mean is the sum of all the values divided by the number of them. If a set of numbers is arranged in order of size, then the middle term is called the median. If there is an even number of terms, the median is taken as the mean of the 2 middle terms. So basically that means you add the 2 middle terms and divide by the number of middle terms. Then next we have the number of terms any particular number. The number of times any particular number occurs in a set is called its frequency. And the number that occurs most often is the number that has the greatest frequency, which is called the mode. So following from that example, this example 4, we have to find the mean, median, and mode of the following set of numbers. So these are 12, 16, 8, 11, 12, 8, 2, 8, 1, and 14. So in this case, we have the numbers here. And what we are going to do is, we are simply going to, for the mean, we are going to add the numbers. So the sum of numbers is 92, and the number of numbers is 10. So the mean will be equals to the sum of numbers divided by the number of numbers, that's 9.2. Then next, moving on to the median. As I mentioned earlier, the median is the middle number when you arrange in ascending order. So when we arrange these numbers in ascending order, we have the middle numbers are 8 and 11, So when we look for the mean of those middle numbers, the median will be equal to 8 plus 11 divided by the number of middle numbers, that's 2. 8 plus 11 divided by 2, that's 9.5. That's median. Then finally, looking for the mode, we have the mode as 8. The reason for this is that 8 occurs most often in the data. So 8 is the most occurring, that's why it's the mode. Up till now, we've been dealing with ungrouped data, but there's another part of statistics that deals with a subset called group data. And whenever we are dealing with group data, we involve histograms, cumulative frequencies, curves, and so on and so forth. Now, this group data, let me give an example. And this example 6, we are asked that this is the frequency distribution table of the masses of 40 students in a class. Now, these are the 40 students. The first column is the column of masses, and the second column is the column of number of students. Now, we are asked to draw a histogram of the distribution, to state the module class, to calculate the mean mass of the students. Following from the previous example, we are also asked to draw a cumulative frequency curve, OG curve of the distribution. Then finally, we are asked to estimate 1, the median, and 2, the semi-interquartile range. Now just follow me carefully. I will go through these different questions and we will solve them in sufficient detail. Now first of all, you need to understand that the first part, let's first of all draw the first part of the question, which is for the histogram. So now we are required to draw a histogram. Now just as you have noticed, a histogram is just like a bar chart, but the only difference being that the histogram has no space between the bars. So as you can see, these rectangles, they are jointed from end to end. There are no spaces between the rectangles. So all we can see are the form lines. Now this is called the histogram, and aside the jointed nature, it's very similar with a bar chart. But another subtle difference that you might not notice is that we don't use the class limit, we use class boundaries. Now, how do we get these class boundaries? Now the class boundaries are gotten from the class limit. The lower class boundary is gotten by decreasing the lower class limit by half, and the upper class boundary is gotten by increasing the upper class limit by half. So as you can see in this case, when you look at the horizontal scale, we have 0.5 for the first, in the beginning of the first rectangle. Then we have 45.5, 50.5. So that is gotten by decreasing and increasing the limit by half. Moving on to the next part of this question, we have that is the required histogram which we've drawn. Then moving on to the next part, we have the modal class, which is 51 to 55, because this is the highest class. It has the highest frequency, and the modal class also corresponds with the class on the histogram that is the longest rectangle. So then moving on to the next part, we have the mid value of each class is taken to be representative of that class as a whole. So that is, in this next part, we are asked to look for the mean mass of the students. So now let's take the mid values, and the reason why we are using the mid values is that we are going to use the mid values to evaluate the mean. And here we are going to use two different methods, so I will explain these two methods. Now first of all, when you are evaluating your mean, the first thing you need to do is you draw your table of values. So in this case, we have our masses in the first column, we have our frequencies, which is the number of times we have those masses. Then we have the mid values, which is the average of the class limits of those masses. For example, the mid value of 43 is gotten from the class 41 to 45 by adding 41 to 45. So you add 41 plus 45 and you divide by 2. So you get the mean of the class limit. Is also known as the mid value. So that is in the third column of the table. Now in the fourth column of the table, we have the deviations, which is when you subtract the working mean from the mid values. Now the working mean is also known as the assumed mean, and basically we make use of that working mean when we want to use it as an alternative method to get our mean. Then for the last column, we multiply the frequency and the deviations. Then when we sum those deviations, that will give us sum of deviations. And then the reason why we are summing the deviations is that we are using that deviations to add to the assumed mean. So the mean is equal to the sum of the assumed mean and the total deviations. So these total deviations, we also have to divide them by the number of data. So let's try out the next part of this question, and that is the using the mid values only. So in the first method, let's use only the mid values, and this is the first method of looking for the mean. when we use only the mid values, you are going to multiply the mid values and each frequency. Then you divide by the total number of masses. That is, when you do that, in the numerator we have 2195. In the denominator we have 40. When we divide, that will give 54.875 kilograms. So that is the using the first method. Or we could use a working mean or an assumed mean. And when we use an assumed mean of 53 kilograms from the table, we'll get that the mean deviation is 75, which is positive. Then you divide by the total number of masses. So that plus 75 is the total number of deviations. So the mean deviation is now plus 1.875. Then the mean mass will be the addition of the mean deviation and the assumed mean. So you can see that at the end of the day, we still get the same answer, which is 54.875 kilograms. Now, moving to the fourth part of the question, we are asked to draw a cumulative frequency graph. Now, before you draw a cumulative frequency graph, you need to draw a cumulative frequency curve, or rather a cumulative frequency table. And this is the table here. In the first column, we have the masses. In the second column, we have the frequencies. In the third column, we have the cumulative frequencies. Moving on to the next part of the question, we have the cumulative frequency graph. Now, this is gotten by plotting your point, and this is on the horizontal axis. We have plotted our lower, or rather, we plotted our upper class boundaries. Then on the vertical axis, we've plotted the cumulative frequencies, and the cumulative frequencies are gotten from adding the successive frequency. So when you add them together successively, so just as in the previous table I showed, so you keep adding the successive frequency till they add up to the total of number of data. So that's how to get your cumulative frequency. And then you plot, when you plot your upper class boundaries against the cumulative frequency, you get your cumulative frequency curve, and this is called an O-give curve. Now, from that cumulative frequency curve I gave earlier, we can also use it to calculate many things about the data. For example, we can use it to calculate the median and semi-interquartile range. Now, the median is basically the half of the cumulative frequency curve. So what that means is it is the 50th percentile of the cumulative frequency curve. So what you need to do is you divide the total cumulative frequency. In this case, it is 40 divided by 2, which is 20. So you can also check the graph in the previous picture I showed. Now you can also go back, rewind the video and go back to that graph. You will see that your median is cut at the 20 points, and then when you trace it horizontally to meet the cumulative frequency graph, then you now trace it vertically downwards to meet the horizontal axis. You will cut it at a point that will correspond to the median. So in this case, we have it as 55 kilograms. Using the same method, you can also look for the semi-interquartile range. So, but the semi-interquartile range is defined as the is half the difference between the upper quartile and the lower quartile. So what this means is the upper quartile is the 75th percentile and the lower quartile is the 25th percentile. So what you need to do is you look for 75% of the total cumulative frequency curve for the upper quartile, and then 25% of the total cumulative frequency curve for the lower quartile. Then when you subtract the lower from the upper and divide by 2, as in this case, that is 59.5 minus 50.5 divided by 2, it will give you 4.5. That will be the answer for this question. So I hope you understand this question. In order to test your understanding of this question, I have displayed a question on the screen now. So on this question on the screen is a test for you guys. So you can just try it to know how much you understand the topic of statistics. And after you try it, you can also post your answers as a comment, or you can post it in the send it as an answer or a picture to the WhatsApp number in the description of this video. So now that is all for statistics. Let's move on to the second part of this video. And in this second part, we'll be talking about probability. Now let me just give a short introduction of probability. Probability has to do with the chance of an event happening. So when we talk about probability, we're talking about how possible is it for something to happen. That is what probability is. And the probability of an event happening is given as the number of required outcomes divided by the number of possible outcomes. You might have come across that. That is the general way of understanding probability. Now, probability is quite simple, very simple. So I'll just give an example. Yeah. Now, this first example is we are given the number of students in each age group of the class, and in the first row we have the age, and in the second row we have numbers. Now, what is the probability that a student choosing at random from the class is number A, 17 years old, number B, not 17 years old, number C, not 16, so rather over 16 years old. Let's take our time with this question. Now this is the data. For the number A, we have the probability that the student is 17 years old is equal to the number of 17 years old divided by the total number of students. That is the relative number of 17 years old. That would be, in this case, the number of 17 years old in this table is 22. Then the total number of students is the sum of the total numbers in each age group. So that would be 7 plus 22 plus 13. That would be 42. So when we take the ratio, that's 22 over 42. So that would be the probability. So probability is all about ratio of, it's all about the relative frequency that an event will happen. Moving on to the next part, we have the probability that a student is not 17 years old. Now, you note that in the first part of this question, we said the probability that a student is 17 years old is 11 over 21. So now, what will the probability that the student is not 17 years old be? So in this case, all you need to do is subtract your probability from 1. So in this case, that's 1 minus our previous answer, which is 11 over 21. 1 minus 11 over 21, that's 10 over 21. So in this case, the probability of an event happening is equal to, and the probability that it doesn't happen, they add up to 1. So because of this, when you subtract from 1, you will get the probability that it doesn't happen. So that is why it is like this. Moving on to the next part of this question, we have the probability that the student is over 16 years old. It will be the number of students over 16 years divided by total number of students, and that will be 5 over 6. Next, let's quickly go over something which you need to understand in probability, and this is called the addition law. Now, first of all, let me explain what addition law means. In probability, some events are addable, or rather, they are mutually exclusive. So that means when you say mutually exclusive, it means it is not possible for those events to occur at the same time. For example, it's not possible for you to be both black and white. It's either you are a black or you are white. Now, in this case, when we are looking for the combined probability of those events, we add them together, and that is called the additive law of probability. Now, in order to demonstrate the additive law of probability, I'll give an example here. And this example, we are told that a letter is chosen at random from the alphabet. So we have to find the probability that is either in the word pyramid or in the word cone. Now, the word pyramid uses 7 of 26 letters of the alphabet, and the probability P of choosing a letter of the word pyramid is 7 over 26. Similarly, probability PC of choosing a letter of the word cone is 4 over 26. So what we are going to do is we are going to add together this probability because they cannot be, they are mutually exclusive. So we are going to use the addition law. And what mutually exclusive means, let me remind you, it means that they cannot occur at the same time. So what that means is that the letter is either choosing from the word pyramid or it's choosing from the word cone. So when we add the probabilities, we have our total answer as 11 over 26. Now I'm quite sure that addition law was easy. Let's go on to product law. And when we talk about product law, we're talking about when events they are not dependent. So that means they can happen together because they are independent of each other. So if events A, B, C, and so on are independent, the probability of A and B and C and so on happening is the product of their individual probabilities. So in product law, it happens for dependent events. So that means if you have events that can happen independent of each other, you just multiply their probabilities. So I'll give an example to illustrate this. In this case, we have example 12. A card is chosen from a pack of 52 playing cards without replacement. A second card is chosen. What is the probability that they are both clubs? Now, this is a common question of probability. It's about cards and all this rest. Now, the first choice. In the first case, the first card he chooses, he has to choose one out of the cards. And then in the first choice, there are 52 cards and there are 13 clubs. So the probability of choosing a club will be 13 over 52. And when we break the fraction to the simplest term, it is 1 over 4. Now, after he has taken a card, he has another choice. Now, when he has taken a card, the remaining cards in the box are now 51. So that is one less than the original number of cards. So that he has to choose out of 51 cards, of which we have only 12 left. So he has to choose 12 clubs out of 51 clubs. Now, because these events are they can't occur, they are not occurring at exactly the same time, so they are occurring one after the other. So that means they are independent. So we can multiply their probability using product law, and then we have 1 over 4 times 12 over 51. That is, at the end of the day, we have a probability of 1 over 17. Now, the product law is used to solve problems that contains the word and or both and both. So now, let me give a tip for you guys to understand this question better. Now, just in case you were having issues with the previous question, I want you to note the following: that a coin has two faces, either head or tail. A die has 6 faces, which are numbers 1 to 6, and the plural of die is dice. A pack of playing cards has 52 cards, consisting of 26 red cards, 26 black cards. It also consists of 13 clubs, 13 diamonds, 13 hearts, and 13 spades. And finally, it has 4 aces, 4 twos, and so on, up to 4 tens, and 4 jacks, 4 queens, and 4 kings. Now, these are the different ways you have 52 playing cards classified. And because of this, you have different names for each of the parts of the card. So this often comes down to probability. If it comes out, you can still use this to understand it, that there are clubs, diamonds, hearts, and spades. There are aces, there are twos, there are fours, there are six, there are sixes, there are eights, there are tens, there are jacks, there are queens, there are aces. So this is a key for understanding that previous example. And finally, this is as far as we can go in this video. I hope you've understood the concept of statistics and probability, and I hope you enjoyed the video. Please don't forget to like, share, and subscribe to continue receiving educational content like this. Thank you.